And again, welcome to today's webinar, Power Your Digital Marketing Strategy with Amazon Web Services. Our presenter today is Ben Butler, Senior Product Marketing Manager for Big Data at Amazon Web Services. We provide Ben's profile in the presenter window on your console. Ben, you have the floor.
Thank you very much, Anna. Thank you everyone for taking the time today to learn about how you can use the Amazon Cloud to power and enhance your digital marketing strategy. Again, my name is Ben Butler, and I'm the Senior Product Marketing Manager for all services and activities related to big data at Amazon Web Services. And you can see there's my Twitter handle. It's also for LinkedIn if you'd like to send a direct message to me after the webinar. One growing segment of our customer base is in the digital marketing space. What we'd like to do today is introduce AWS and how we can run a successful digital marketing campaign on top of our platform. Here are the topics that we'll go over for this webinar. We will introduce Amazon Web Services, and successful digital marketing workloads that you can run. We will review at a high level some of the services of our platform and then dive a little deeper into Amazon DynamoDB, our NoSQL managed service, and Redshift, our data warehouse as a service. Then we will show you how you can create architectures using our services as building blocks to create an ad-serving real-time bidding system on AWS. Then we'll conclude with some public examples of digital marketing customer success stories and do a little short Q&A at the end. Before we get into the technology of AWS, I'd like to spend a moment discussing the business, operational, and financial value propositions for moving to the cloud. From a business perspective, you can have a faster time to market, you can iterate faster, learn faster, and be able to pivot to another direction or strategy as you see fit in a more agile fashion. And because you don't have to worry about building or managing the undifferentiated plumbing, it's very important in the rapidly changing digital advertising ecosystem. And then from an IT operations perspective, you can add new capacity with an API call or point and click from our console, as opposed to physically handling the infrastructure to scale. Furthermore, there are a lot of digital marketing firms already on AWS, so you can have lower latency access to those platforms in the real-time bidding ecosystem, for an example. And then from a financial perspective, we offer a flexible pay-for-what-you-use, when you use it, with no commitments or contracts, and a self-service model, and avoid investing in lots of capital to start a campaign or invest in large capital expense, which you can then transfer to operational monthly expense. And so here are some use cases of what digital marketing companies do for Amazon Web Services, such as what we'll talk about later, ad serving infrastructure. So having ad exchanges and demand-side platforms and supply-side platforms, interactive campaigns and microsites, product websites, games and contests, or high-performance computing and big data, so on the back end doing ad analytics, ad server log processing, and feeding data for business intelligence. And here is the AWS global infrastructure. We have the concept called regions. We have 9 regions throughout the world. These regions constitute one independent Amazon cloud. So in a sense, we have 9 clouds worldwide. And each region is designed for high availability with the concept of availability zones. Availability zones are a cluster of one to many physical data centers grouped together to provide high scalability and durability within a particular region. And so we have 4 in the United States, 1 in Brazil, 1 in Sydney, 1 in Singapore, Tokyo, and in Ireland. And we're growing massive infrastructure in those regions every day. So if you consider Amazon.com, our retail in 2004, we were a $7 billion e-commerce platform. And think of the infrastructure, the server, the networking, the compute capacity that we needed to do to handle that e-commerce platform. We handle that every single day by adding that capacity to Amazon Web Services. That's essentially a Fortune 500 company business infrastructure that we're adding to AWS every day. So we're making massive investments globally. And so it's maybe hard to see, but we have the red dots and the orange stars. The orange stars are those 9 regions, And the red dots is a completely separate set of networks for what we call edge locations, or points of presence, with lots of caching servers and DNS servers for our Route 53 for domain name system services, as well as CloudFront, our content distribution network, to be able to get, for instance, in digital marketing, your ads to your end customer at the lowest latency physically possible. And we continue to add that every day. And so let's take a look here at some of our successful customers running on us in all types of industries, from industries or enterprises such as NASDAQ or Samsung and Royal Dutch Shell, to public sector such as NASA or the Center for Disease Control, or hot internet properties such as Netflix. Organizations of all sizes, from startups to enterprises to government entities, have been able to innovate and solve problems using our elastic cloud infrastructure. And because we provide a lot of core benefits of cloud computing at scale, such as what I mentioned before, paying as you go, and lowering the overall cost, we have reduced costs 38 times since we started in 2006. So we consider ourselves 7 years young when we launched S3 in 2006. And of those services, we've done significant price reductions as we have hit economies of scale and passed those cost savings that we've achieved on to our customers. And then the self-service model, being able to provision the capacity that you need and going global in minutes, just like what you saw with our regions worldwide. So what we try to enable is we remove the heavy lifting from our customers, from you having to procure and manage those services yourself, so you can focus on your business or mission that differentiates your organization from others. So what exactly is AWS? We know it's cloud computing, but let's talk a little bit deeper about our platform. So we have a whole portfolio of over 35 plus different web services that range in the high-level categories: our global infrastructure, our networking, compute, storage, and database, application servers, and deployment and administration. So what I like to do is just do a high-level overview of some of the services throughout our cloud stack and be able to describe some of their benefits. And then we'll go a little bit deeper into Redshift, Amazon Redshift, and Amazon DynamoDB, and how they specifically can help the digital marketing industry. So we'll start with compute services. Amazon EC2 Elastic Compute Cloud are our virtual servers in the cloud where we can run on virtualized Windows or different variations or distributions of Linux. We also have different families of instance types that have different profiles of memory, compute, and networking capacity. And you pay for these by the hour, and you'll be able to launch 1 to 50 to thousands of instances to help with your whatever demand that you need to serve. And auto-scaling is a service that works for EC2 by being able to provide basically an automated policy engine which enables you to dynamically scale your EC2 infrastructure based on parameters and metrics that you've decided. So for instance, if your CPU utilization is over 80% for more than 5 minutes, you may add another server into your fleet. Or if there's a server that went down and it failed a health check, then I'll be able to scale that up automatically. You can even use auto-scaling for one instance. So if that instance goes down, you can have another one replace it automatically and be alerted to it. And so auto-scaling is basically a free service that we offer which enables you to manage your EC2 fleet more effectively and at scale. Elastic Load Balancing is a dynamic traffic distribution service which will take web requests and distribute them across multiple EC2s instances that may be in multiple availability zones. And we'll see how ELB, which we will call it, leverages in a digital marketing campaign infrastructure. Now we'll move on to some of our big data services. Elastic MapReduce is a service which is basically a hosted Hadoop framework. It's taking the paradigm of Hadoop, of distributed parallel processing, taking large data chunks, breaking them up in small bits, and having each node in a particular MapReduce cluster, Hadoop cluster, work on those individually, and then be able to aggregate or reduce those results to a final end product. Hadoop is innovation in massive distributed computing, but you would still have to manage the infrastructure yourself or on EC2 if if you wanted to or if you had to. But what EMR, Elastic MapReduce, enables you to do is be able to take the power of EC2 and allow us to provide a managed Hadoop platform for you so that you can work on your analytics and less on the infrastructure of managing Hadoop. Then we have Amazon Redshift, which we'll get into more detail later, but it is a petabyte scale data warehouse managed service for your big data needs. And then you may want to be able to move data across different services within the cloud or to on-premise data sources as well. And you may need to automate the scheduling of moving those data. So for instance, log files that are going to go into Elastic MapReduce where the outputs go into a bucket, and you want to be able to do that per hour, per 5 minutes, or per day. A data pipeline enables you to automate those workloads. Then we'll go into database and application services. So you can run your own database on EC2. You have the system admin privileges and the root ownership to be able to do that. But you may want us to handle even more of the heavy lifting of managing actual database engine. So the relational database service, we will manage an Oracle instance, MySQL, or SQL Server from Microsoft. And we'll do that where you can bring your own license, or we can add additional costs to the hourly rate to be able to manage a relational database for you. And then you may have workloads that you want to go at scale and not necessarily in a relational format, but more of a key value store or document or self-describing data in JSON format. We're able to do that at scale with Amazon DynamoDB, which I'll get into a little bit later on. But it is a NoSQL database service that's managed for you as well. Then I talked about briefly content delivery network, which we call Amazon CloudFront. This is using those red dots I was talking about in the previously, where you distribute the content globally and fast to lowest latency possible to the end user. So basically what CloudFront does is it caches from an origin server, which can be an EC2 instance, your own instance on-prem, or an S3 bucket. And so that's staged, and then you can cache it into Amazon CloudFront, which then we use records, and we do our own big data analytics to determine the lowest latency path to get to that particular end user. And then you can also leverage the power of the A9 search engine platform that powers Amazon.com by having your own instance in Amazon Cloud Search, which is a managed search engine service that you can ingest large amounts of data into, be able to index it and have faceted types of queries, all without having to maintain a search engine infrastructure. And then we'll go into storage services. Amazon EBS, Elastic Block Store, is basically networked hard drives from 1 gigabyte in size to 1 terabyte in size and in 1 gigabyte increments. So you can have a 512 gigabyte hard drive, which then you can scale up to 1 terabyte if you need to, and be able to attach these hard drives to your EC2 instances. This is where you would install your applications or your data that you need to have persistent storage, and the ability to be able to remap these drives to other EC2 instances gives you some dynamicism. And now we have Amazon S3. Amazon S3 is a web object store at internet scale. It is the first service that we offered, and you can store any object, which is any file, from 1 byte to 5 terabytes in size. It is architected for 11 nines of durability. It's stored in multiple availability zones as a managed service. And at last count that we offered out, that it holds over 2 trillion objects. And each object is stored a minimum of 3 times. Now, it took about six and a half years for us to reach our first trillion, but with the massive adoption of S3, we hit our second trillion only shortly 10 months after that. It goes to show you the scale and the rapid adoption of AWS. Then we have Amazon Glacier. Amazon Glacier is cold storage for archiving and backup. If you have tape solutions that you want to move to the cloud, Amazon Glacier is the perfect fit for that. It is 1/10 of the cost of S3, but with the same levels of durability. You just have to wait from 3 to 5 hours for the retrieval from the cold storage. Then we have Storage Gateway, which is an integration of being able to migrate from on-premise workloads into the cloud, and you can have cached volumes that are in your own data center. and then you use those cache volumes for the low latency and performance requirements and have them asynchronously, automatically, and securely backed up into the cloud, which is really great for migrating workloads into the cloud with exact copies of blocks from your hard drives locally, or for migrating and backing up into the cloud. And here's just a snapshot and a vibrant ecosystem of digital marketing and advertising system companies that are running on AWS. And we'll go through, after we go through some of the architecture, some of these companies that have great success running on AWS. So what I'd like to talk about now is Amazon DynamoDB. This is our managed NoSQL database as a managed service. So make sure that comes through. So it is a NoSQL managed database. It offers predictable performance where you specify the number of reads and writes that you need to have at the table. It's seamless and massively scalable where we will partition out more and more hard drives as needed to handle the size of your tables. You don't have to worry about the table size or being able to manage the partitioning. We'll do that for you. So it's fully managed with zero admin. And so what Amazon DynamoDB provides is the database software, the scaling without downtime, the automatic sharding, the security inspections and patches and upgrades that we're able to do, the automatic hardware failure in case a drive or a server goes down, we'll do that for you. And it's multi-availability zone replication, which I talked about earlier, where we had a region, and a region has multiple availability zones. So when you use Amazon DynamoDB, it automatically uses multiple availability zones as part of the managed service. And then hardware configuration is specifically designed for DynamoDB for maximum performance and for tuning. So how did we come to DynamoDB? Well, we took our lessons learned from Amazon.com, and so this is a white paper that we released about 10 years ago now, and we've made dramatic improvements to that type of technology. But what we've done is done a collection. It's the result of everything we've learned from building large-scale, non-relational databases for Amazon.com and building highly scalable and highly reliable cloud computing services from AWS. So putting those two together, we're able to come out with DynamoDB. And what we'll do is go over some of the benefits from multiple users of DynamoDB. So we have developers, operations, and end users or business users. And for developers, it allows for fast application development. Gives you time to build new applications, flexible data models where we don't enforce schemas, a simple API with only 13 different API commands, basically creating a table, inserting items, which are basically like records in a table, adding or putting into attributes, reading those, and then being able to describe the table. So it's a very simple API, but can handle high-scale queries and lots of API calls. And then we also offered recently is DynamoDB Local, where you can do development on your own laptop to understand how the DynamoDB API works, and then be able to upload or put that type of code against a real DynamoDB table on AWS. And for the ops users, this is where it's admin-free at any scale. You basically give a few parameters of what your table is, what the level of read capacity and write capacity is, and we call that provisioning throughput. And that enables you to be able to scale up and scale down dynamically without downtime. And DynamoDB handles the rest. So you don't have to worry about racking and stacking servers or hard drives to be able to handle databases at large scale. So you can create a table, and for instance here, it's at 100 reads per second, 150 writes per second, and then you can update that table many times to even get scales of, it says here 10,000, but I've seen hundreds of thousands of read writes per second. And so DynamoDB is able to handle that. It's scaling up and triggers repartitioning and reallocation of solid-state hard drives with no impact to performance or availability. And now for the end users or the business users, we offer durable low latency, and we'll give a good use case with real-time bidding of why that's important. But you're able to get low latency of reads of 5 milliseconds and writes of 10 or less milliseconds. And then, of course, when I was talking about multiple availability zones, we're able to do writes to multiple availability zones with DynamoDB service in each of those zones. And each of these zones are physical clusters that are separated by tens of miles away from each other, so they're not right in the same area. And they're replicated continuously and persistent to disk, so it's not in memory. These are on solid-state drives. And you can have reads that are strongly or eventually consistent with no latency trade-off. The trade-off is the read capacity throughput is halved for when you want to do strong, consistent reads, because then it has to read to multiple zones at the same time. Now I'd like to segue into Amazon Redshift, which we launched earlier this year. This is our database warehouse as a service, as a managed service for you that can go to petabyte scale. And to give you a little bit of a history of why we decided to do this, as opposed to just using a normal traditional data warehousing, is we wanted to do it the AWS way. And customers asked us, we'd like to have a data warehouse that's easy to provision, normal AWS criteria basically for creating web services, pay as you go, no upfront cost, no commitments, fast, cheap, easy to use, and open and flexible. So we support SQL in terms of Postgres wire protocol to be able to support that, as well as enabling JDBC and ODBC connectivity to the cluster itself. And here are a couple use cases of Redshift and DynamoDB, as well as some of the other services. We have customer acquisition for ad spend and figuring out traffic sources where you're getting your customers, the behavior, the click streams, the referrals and sharing, the actions taken, what did they click through, what are your click-through rates, and then overall lifetime value when you want to do business intelligence tools or custom applications that are doing query requests to Redshift in terms of what are the conversions or the churn rate or loss of customers over periods of time. So let's talk a little bit about the Redshift architecture, just go down a little level deeper. So Redshift is a cluster of multiple EC2 instances together running as a managed service on your behalf. But for you as the user, you just have to worry about that it's a database and that you're interacting with it through the leader node, and the leader node does the management of all the other back-end compute nodes within that cluster. So the leader node is the SQL endpoint. It stores statistical metadata about what's on each of those nodes. It coordinates the query execution by compiling code and being able to pass it on to the compute nodes. And the compute nodes have local columnar storage, and we'll go into some of those details in a minute. But it executes queries in parallel, and then also parallel loading from S3 and DynamoDB as the primary ways to get data into Redshift. And then there's also a single node version available for really for development purposes and use case development. And that is where the leader node and the compute node are co-located on one instance. And in all cases, except for the single version, no matter the size of your cluster, the leader node that instance is provided to you as a part of the cost, and then you just pay for the size of the cluster with the compute nodes. And Redshift runs on optimized hardware for this type of workload, where it's using the HS1 8 extra large instance, and then that's segmented for Redshift. So you can go to EC2, and you can get your own HS1 8 extra large instance and be able to run large workloads yourself. But for Redshift, we're using the same type of EC2 instance for this particular data warehouse workload, where for the 8 extra large instance, you get 128 gigs of RAM, 16 cores, 24 spindles of with 16 terabytes of compressed user storage. So we can compress between a factor of 2 to 8 from a normal database. So if you have a 64 terabyte database, you can get that maybe to 16 terabytes or 32 terabytes depending on the compression. And then a 2 gigabyte per second scan rate. And then we have the extra large. So with these being virtual machines, the extra large runs on that same physical hardware, but it's exactly 1/8 in all dimensions of RAM, of cost, of spindles, and of cores to be able to do that. And so Amazon Redshift parallelizes and distributes everything. From querying, we'll go through a couple of the use cases of how it does this, but from the query, it goes into the leader node, which the query is then parsed, and then an initial query tree is sent to a logical transformation, and it matches what the data in the different tables and different rows and columns, where that's stored on the cluster, and be able to have a physical plan, and then compiles discrete C++ code that gets sent to each of the clusters, and then each of the compute nodes works on their specific task in parallel to dramatically reduce computation time for queries at scale for billions of records. And then now for loading, you can use either Amazon S3 or DynamoDB to load in parallel. So it's not, you send the command to the leader node, and then each of the compute nodes behind that cluster will go to S3, where S3 and DynamoDB are already handled to scale multiple client requests, multiple users on data files. It can handle the requests from the cluster nodes. And so you can load in parallel. It's in columnar storage, which means if you have a database table with a lot of fields, each of those fields or columns in that table is laid sequentially on disk, which reduces the amount of seek time that the head of the hard drive has to locate that information and do the query plan. So this scales linearly with the number of nodes that you have in your cluster. And now for backup and restore, a part of this managed service is that it backs up to Amazon S3, and it's automatic and continuous and incremental for you. That way, if the cluster, for instance, ever fails or you need to make another copy of it, maybe you want to run some other business analytics tools, then you can use those snapshots. You can also create user snapshots as you seem fit too. And then there's a streaming restore. So as queries are being put to the cluster, it will grab the data dynamically to whatever is on each of those nodes and stream it from S3 first. It basically prioritizes the type of data that it retrieves during a restore. So that way, when you're trying to do a restore, you don't have to wait for the whole petabyte scale data warehouse to be up and running. You can do it near real time after it's started the restore process. And now for resizing. You can resize your cluster going up or down while remaining online. And the way this works is that we provision another cluster to the new size that you want, and we copy data from node to node in parallel to the new cluster. And you're only paying for the source cluster until the new cluster is up online. And so how this works is we still allow reads for the old cluster, but we do suspend the writes until the new cluster is put in place. And then once that's handled, then we do a DNS switchover, and then the new cluster is in place. And you're only charged for the source cluster while that resize is happening. And this can all be done as a simple operation via the AWS console or through the API. And here's just a little example of how you can start small and grow big with Amazon Redshift. You can have a single node that's 2 terabytes, or if you're using the HS1 extra large instance types, you can have a cluster between 2 and 32 nodes, which gives you up to 64 terabytes of storage for your data warehouse. And keep in mind, this is of compressed space. So you actually may be able to have a larger than 64 terabyte data warehouse that could compress onto this one. And then for our largest scale is the HS1 8 extra large, which enables you to have 1.6 petabytes, where you have each of these 8 extra larges providing 16 terabytes of storage for the data warehouse. And so Amazon Redshift is easy to use. You provision it in minutes, usually around 15 minutes in it. Because we scale linearly and in parallel, a 1.6 petabyte cluster would take nearly the same time as a 64 terabyte cluster because of everything happening at the same time. And then you can monitor query performance in the console. You can do point-and-click resize, which we talked about. It has built-in security, AES 256 encryption, and automatic backups. All of the managed data warehouse service that's easy to use without you having to worry about the heavy lifting. Now we'll talk a little bit about ad serving and how that plays in a real-time bidding system. So if you look at ad serving, we have a visitor, and the visitor is loading up a web page in their browser. And the web page is issuing a request. It's built into the HTML to add a request to the ad servers on EC2. And so the ad servers then are going to determine what ad to place to that server. And it may do that by querying DynamoDB to figuring out from the session cookie, which can also be stored in DynamoDB, what ad to return back and what's the most relevant. And then that link is returned to the visitor in form of a URL to access the resources to fill that ad to the web page. Now, for real-time bidding, you want to be able to have more of a dynamic system where the people who are holding the inventory want to monetize their space for ads, as well as the people that are giving real-time bidding ads. They want the supply side. You want to be able to make sure you're making the right investment. So real-time bidding allows advertisers and publishers to buy and sell online display ad inventory in an efficient, high-speed marketplace. And the real-time bidding platforms solicit bid requests for each ad impression from multiple exchanges or advertisers and pick the highest bid. Auctions occur real-time while end users wait for content to load in a browser or an application even. The impact on end user latencies places strict time constraints on the decision-making ability and the latency of these bidding systems and built by ad exchanges and advertisers to compete in this ecosystem. So let's drill down into that, where each ad served using RTB involves complex real-time interactions between the content systems, the ad servers, a real-time bidding platform, and multiple ad exchanges. The process has to complete under strict time constraints because we're doing this in milliseconds as the browser is loading. And typical bidder latency requirements are in the 50 to 150 millisecond range to ensure that the ad opportunities are not lost due to ad serving delays. So it's critical that we have high-speed performance. Because separate companies own the bidders and the RDP platform, systems hosting these services can't all be in the cloud or they can be in different data centers. So if you assume a latency requirement, say, of 100 milliseconds, network round-trip latency of 40 milliseconds, and a buffer of 20 milliseconds to count for network jitter or queuing delays, then the bidding system has only 40 milliseconds to decide on a bid to indicate which ad that you want to serve and what the bid price is. And there may be multiple rounds of bidding within that time period. So even if the application is heavily optimized for computation and data access, the available time is really short for individual data fetches and writes. And this is on the order of single-digit milliseconds. And this is where DynamoDB is poised to handle this type of workload. So what we'd like to do is now let's scale this ad server infrastructure. And what we'll do is see how DynamoDB can and Redshift can support this type of use case. So here, for the ad servers, instead of directly having the web page go to the ad servers, what you want to do is put in an elastic load balancer and place those ad servers in multiple availability zones, so you can maintain that EC2 capacity in multiple physical areas, and then having auto scale so you can add more capacity and handle high volumes of traffic, and then be able to hit that to a managed, highly scalable state store that's in DynamoDB that's holding cookies and profiles. And so say you go through that process that we described earlier where you're making those ad servers are making those bids and they say they win a bid. And what happens is that the advertisements are statically stored in the origin servers, say in S3, and then they're cached to CloudFront, which then you can get with the quickest latency possible or the smallest latency possible, serve that advertisement to that visitor. And so the ad files are downloaded from CloudFront, and then CloudFront as a service will capture those impressions into logs and place them onto S3. And then, so you served up the impression, you've won your bid, and then the user has looked at the ad and they've clicked on it. And so this can go through another set of workload of servers where you front that as well with an Elastic Load Balancer, and that hits a fleet of auto-scaled and multi-availability zone EC2 servers. And these are click-through servers, which will then capture those requests as well as forward to wherever you want that ad to go, to another set of website or wherever you want that landing to happen, and then send those click-through log files also being stored to S3. And so you can see this pattern here where we've got all these managed services that can scale automatically for you, that you can create these workflows and then be able to push those data files in big data or fast data into managed services such as S3 and DynamoDB. Now let's talk a little bit about the analysis side. So we've done the real-time bidding, we've given an impression, ad impression, they've clicked through it, we've sent some logs, and now we want to make some decisions or get some insight out of those logs. And this is where Redshift comes in. And so what you can do, and Elastic MapReduce. So you can take those unstructured or semi-structured log files, be able to process them in parallel with an Elastic MapReduce cluster, do some extraction, transformation, loading into Redshift, and Redshift now can be this canonical place to hold all of your data, such as from DynamoDB you need the really quick low latency access, but then you want to be able to provide the historical updates to user profiles, update to session cookies, whatever, new bids that were placed, and place the data into Redshift. And then now Redshift is a canonical place that can then support a business intelligence tool. So let's take a look at that. Here we have business analytics using Redshift, and a couple of use cases is a bid optimization or cost optimization, where we've used our scalable data storage services and Elastic MapReduce analytics services to be able to provide enrichment, user history, third-party data, impression data, clickstream logs. All of that has now been formatted to place into Redshift, which then can handle and support business intelligence tools or custom applications that can hit against that endpoint. So you may already have a Tableau or a MicroStrategy or a Jaspersoft or Cognos, any of those well-known business intelligence tools that support a SQL open interface can then do those analytics against Amazon Redshift, such as recurring reports, and being able to do that at scale where you don't have to worry as you're adding more data, Redshift can handle that load. Or like what I talked about with Redshift earlier, being able to increase the size of the cluster if you need to. So I've gone over a couple of architectures for real-time bidding and ad serving. We have at aws.amazon.com/architecture an architecture center which has some icons of in architecture patterns for different types of workloads, so actually hosting the web application, the content media serving, or advertising serving, or having those real-time bidding strategies. So go check on our architecture site, and there's a list of several of those that you can download and use for yourself. We also have some simple icons in case you want to create your own cloud architectures as well. So I'd like to talk about a couple of customer success stories that have used our web services in the digital marketing space. And so this is a Fine, and they do contextual targeting, providing relevant ads to their users. And so their customers bid on video and inventory in real time, and their system must evaluate the content they're sponsoring and respond with a decision back to the system within 50 milliseconds. And they also use Route 53. When Route 53 has latency-based routing, so kind of like CloudFront, it will know how to route to a different region depending on the latency. And so that lets them easily run multiple stacks of their entire targeting platform in each Amazon region that they can to meet their customer latency needs. So they deliver certainty to advertisers and agencies within less than 50 milliseconds. And Lamborghini uses Amazon Web Services for dynamic web apps. And so they had a website that they wanted to put up in less than a month, and it was a new product, a new version of a new model of their car, and they wanted to be able to support peak traffic, and they got a 250% burst in visitors because of the new product launch, and they wanted to be able to scale to that without having to invest in local or on-prem infrastructure. And so they measured that cost savings, and they reduced their cost by 50% and reduced their time to market to near zero compared to what they were doing previously. And Razorfish is a large digital media firm, and they use Amazon S3 and Amazon Elastic MapReduce to do big data processing. They have a 100-machine cluster, and they process 3.5 billion records per day of over 71 million unique cookies. And so this allows them to understand that over 1.7 million targeted ads per day. And it used to take them over 2 days to be able to do this processing when they were doing it in-house. They moved it in the cloud and were able to do this within 8 hours overnight, and then increase their client return on the ad spend that they were able to do by over 500%. And Kantar Media uses AWS to scale quickly, and they have on their digital media marketing website of images, they have this little bits of code of web beacons, which allows for understanding site usage, the auditing of advertising on the site or where those images are, the reporting and the content and advertising and personalization information they need to collect. And so they collect, with the little scripts embedded, 45 million beacon calls per day. And so that's hitting this Elastic Load Balancer, which hits the edge servers that puts jobs in terms of to store that information and do analytics on it by these workers. The workers put the results in logs that are semi-structured, which they use a Hadoop cluster to do reports. And they do that at scale. And they're able to use S3 in multiple buckets to be able to sort the logs and the reports. And they've had such large success that they're starting to move their entire data center workload of all various different types onto Amazon Web Services. So thank you very much. I just want to point you to a couple of other resources to learn more. AWS.amazon.com has a very comprehensive set of use cases, but more specifically for this audience, I'd like to point out the digital marketing webpage as well as the big data webpage. And then again, if you have any further questions, we'll have a little bit of Q&A in a minute, but you feel free to send me a message at Ben S. Butler on Twitter or LinkedIn.